Welcome to GK Solution. One of my electrical officer asked the doubt about this separator level transmitter which is used in tanker ships, and he wants to know about the working principle of this transmitter. This is actually a level transmitter. It can be fitted in a normal pressurized vessel or normal some vessel is having some liquid and want to know about the level of the liquid. Okay, so for that this instrument is using a flapper nozzle system, pneumatic system in this. So we will see about the working principle. Before starting to see the working, we have to know about the basic things which is used in the pneumatic system. The main thing is that flapper nozzle. This is a very familiar one, and just a small animation how it is working. First you can see this, then it will be very useful to understand the system completely. So this is the setup of flapper nozzle. So we are giving an input air around 2 bar, it is air, and through one orifice. This orifice diameter, and after the orifice one nozzle is there. The nozzle is very important, and the diameter of the orifice and diameter of the nozzle should be same, so that the 2 bar air after the nozzle, after the orifice, it will become some 0.2 bar. Okay, 2 bar air, if you are giving air before orifice, after the orifice the pressure will reduce to 0.2 bar if suppose the orifice is fully open to the atmosphere. Okay, so what we are doing, one flapper is we kept one flapper in front of the nozzle. So the gap between the flapper and the nozzle, it is variable, and by varying this gap we can adjust the back pressure of the before nozzle. The back pressure is there, that back pressure you can adjust. I will show in the animation, it will be very clearly you can understand. If now at present condition the flapper is in full open condition. Okay, full open, how we can say it is full open, the same orifice diameter and this depth also the same size. So the orifice is now full open. So if you are in this condition, if you are giving 2 bar supply air, then after the orifice that will become 0.2 bar, that will be the output. Okay, suppose if I am making closer this flapper, I will push it inside, so that the gap between the nozzle and the flapper will be reduced. So that what happen, will see if you are closing, what is happening, the back pressure is increasing because that all the air will not release through the nozzle. So the back pressure in this output line will increase. So initially it will be 0. When it is open to the atmosphere, it will be the atmosphere pressure, and if you close it, it will become 0.2 bar. Okay, so maximum 0.2 bar only will come because of this orifice. We are put it to the very small orifice, so that only up to 0.2 bar it will come. So depends on the gap, the pressure will vary. This is the flapper nozzle system. If you are opening, again the pressure will reduce. So depends upon your measuring value. Measuring value is connected with the flapper, then you will get the variable output in the pneumatic side. Okay, this output you can utilize in any other controller or some other heater, or wherever you want to utilize this variations, you can utilize that one. This is the flapper nozzle principle and usage. Okay, and another one, before going to the separator, that level transmitter, we have to see one more thing which is used in the pneumatic system. The next one is that relay. Relay means you can understand in electrical system, relay what is doing. So by low voltage you can make a switch on one relay, and the output of the relay you can connect it on the high voltage. So high voltage switching you can do with the low voltage power supply. The same way here, the variation in the low pressure side you can convert into the high pressure side, high pressure signal. If you have only the output, you see before we saw the output it was only 0.2 bar, 0 to 0.2 bar only, but this output will not carry out any task like changing the control valve position and all. We need more pressure. So with this 0.2 bar we cannot do anything. So we have to increase this variation, like that, amplify the variation, so that we can utilize in the actual controller. So for that, what we are doing, we are using this relay unit. What we are doing, you see the working principle of relay unit, it is very simple. If you are giving the variable output in with the point up to 0.2 bar low pressure, very low pressure output, control outputs, that if you give it in this side, and you are giving one side high pressure 7 bar air in the relay unit. So whatever the variations happening in the 0.2 bar input, it will transfer to the 7 bar output. The same variation will pass on to the 7 bar output, so that the 7 bar is enough for actuating the controllers. Okay. So you will see the animation. If I am increasing the pressure 0.2 bar pressure, now it is a 0 bar, we are increasing to 0.2 bar. What is happening? The air is going and pressing this diaphragm. So if you press the diaphragm, then the valve will get throttled, narrowed. Okay, it will get throttled. So if you throttle, then the 7 bar air, normally it is going through the leak off, and the pressure will be less, because all the air will not go to the output. Some of the air will pass on through the leak off hole, and so that the output pressure will be less. If it is 7 bar, it will maybe a 1 bar. Okay. If you are increasing the pressure, what will happen? It will close the valve. The pressure will go and act on the upper side of the diaphragm, and the valve will get closed. Okay. If it is closed, then the leak off will get shut off. Then full 7 bar air will go output. We'll see what is happening. See, if it is closed, then output will go directly here. So according to this variations up and down, the same up and down will converted into 7 bar pressure. So basically we are amplifying the signal. This is the low pressure signal, this is a high pressure output. So this is very useful to operate the bigger actuators and all. Okay, these two principle we can go ahead with the level controller. Level controller is just where we are using this is like a one tank. Maybe it is a closed pressure vessel, or it may be the open tank, whatever it is. It is having two valves. Okay, this oil may be chemical or fuel or some other oil which is dangerous, and if you are putting this oil into the pneumatic controller, then the pneumatic controller will get damaged. So to avoid that, to isolate that, we are using two diaphragm valves. This is simply a diaphragm. One side of the diaphragm, this liquid will touch, and another side of the diaphragm, we are filling with silicone, some semi-liquid fluid inside. Okay, so it is like a more or less look like a grease or some thick viscosity liquid. Okay, it is a silicone. It's actually filled with silicone. Okay, what is happening if your this level, it is here approximately, it is the 50%, so that the pressure acting here and pressure acting here will have little variation, little difference, because of this head. This head is more in this valve. Here there is the same pressure. Whatever this cylinder pressure will be acting on both the valves. Suppose this cylinder is in 5 bar pressure, then this valve also will get 5 bar, and this valve also will get 5 bar. But this valve 5 bar plus this head of the liquid, this height of the liquid also will add on that pressure, so that definitely the pressure difference will be there between this higher top valve and bottom valve. This we have to transfer to the differential pressure unit. Differential pressure unit means the difference has to be given to the flapper. Okay, so what we are doing, we are connecting through diaphragm, so that we can isolate this liquid will not pass on here. So this, whatever the pressure is there, it will transfer to the silicone, and the silicone will go and pressurize the bellows, both the bellows. So here also silicone is filled, both the tube is filled with silicone. So whatever the pressure difference is here, it will react here in the differential pressure unit. Okay, so this pressure unit, if suppose bottom level definitely will be the more pressure than the top one. Okay, so this side pressure normally will be more, and this side pressure will be less. So the difference will act on the flapper position. So the flapper position will be go to the left side. Okay, if it is left side, what will happen? It will closed. You see already it is closed the nozzle. The nozzle is not having any gap. So what is happening? We are giving the supply air to the flapper flapper nozzle system. So the air is passing through the orifice and getting a low pressure 0.2 bar. Okay, that 0.2 bar it has to pass through the orifice, but the orifice we are closed because of this level difference. We are closing a very small gap only we get. That definitely the back pressure will increase, and back pressure is the output. The back pressure is depends upon the height of the liquid in the tank. So if the liquid is more, then the pressure will be more. The liquid is less, then this gap will be more, so back pressure will be less. So this is directly proportional. This output bar from the orifice, after the orifice, the output air from the flapper nozzle is directly proportional to the level of the tank. Okay, so this pressure now we are putting into the input of the relay unit. If you put the relay unit, it will press the diaphragm, so that in the other side in the high pressure side of the relay unit, what we give the supply air directly. Okay, we give 1.4 bar directly to here, and normally that air will pass directly without any loss. It has to pass through it, but we have here through the narrow valve, we have a leak off path is here. So if this valve is open, then most of the air will go to the leak off and go to the atmosphere, and remaining air only will go here. So so what will happen if it is more pressure in the output of the flapper nozzle? It will press the diaphragm and close the valve. Just before we saw that how it is working. So if it is closing, what happens? This pressure will increase. This pressure will go to the controller, or maybe we are giving to the other actuator or indicator, or somewhere we are giving. Okay, so the same output we are giving on positive feedback. This feedback, what is happening? If this is actually positive feedback with the spring we have given. Okay, so this is the positive feedback is for the range. How much you want the range, the signal, how much you want the span of the output range. So for that, what we have to do, here we have the pivot arrangement. This pivot arrangement you can move up and down. Okay, if you are moving up and down, these variations will have the leverage system, and it depends on the distance, it will have a more pressure on it, so that the feedback will react on the output. Okay, so now like this only this system is operating, and this feedback and this pivot adjustment I will show you actually how it is arranged, and how the diagram, how it is working actual scenario. This is only the working principle. Now we will go to the actual setup which is fitted on this transmitter module. We will see how it is. This is the actual this simple drawing I made it, but this is the method they fitted on the transmitter module. So we will see one by one. We see first the valves. Okay, so the valve, bottom valve is connected to the bottom side of the tank, top valve, and this is the isolator. I said it is having one diaphragm here. High pressure diaphragm is there, here low pressure diaphragm. So one side of the diaphragm, this viscous oil or chemical, whatever it is, it will come and pressurize this side. On other side, it is filled with silicon. It is filled with silicon. Okay, this silicon is filled. We should not have any air. It is completely filled. This section pulley, this by line you can trace out this line, and this inside the bellows is fully filled with silicon. This is a bellow. This above the bellow, outer side of the bellow also filled with silicon, but that silicon is connected to the top end of the top valve. Okay, so what is happening? This outer side or inside the bellow, it is connected. It will reflect on the bottom valve pressure. That means that the inside tank pressure plus this level pressure, head pressure. This both the pressure will act on inside the bellow, and outside the bellow, what will happen? This atmosphere or whatever in the top, this cylinder pressure will act on the other side. So that the difference will be only the head. Okay, because the pressure will act both the valve same pressure if it is a pressure vessel. Then only the difference between the valve, only this head. So that will give output from this unit, this DP unit, differential pressure unit. So if you are giving outside the bellow in the top of the valve and inside the bellow bottom of the valve, then this variation, this bellow deflation will transfer to the bar, this transfer bar, power bar. This power bar will directly proportional to the level of the water. Okay, this movement we are connected to the flapper. Here the flapper. So it is directly to the transmission plate. This is called transmission plate. Through the transmission plate, the flapper is connected. So whatever the movement is in the bar, in the moment it is having one small adjustment, suppression adjustment spring also here, because it should not move very freely. So it has to come back. If suppose the bellows is reducing, deflated, that time this rod has to come back to the original position. That is why we given the one spring pressure. Okay. So between this difference, the spring pressure also added along with this bar movement. Okay. So this total bar movement, this movement, here we have a spring plate down below. So it is a movable plate only. So this movement will transfer to the flapper nozzle. Flapper nozzle gap it is varying. Then you are giving, here you see, you are giving a supply air to the pilot relay valve. This is the pilot relay valve. The air is passing through here. Here it is an orifice. I will show you bigger size. Okay. So we are giving 1.4 bar air in the input of the relay unit. Okay. This relay unit, if you give it, this pin is for clearing the orifice. This is for maintenance purpose. They given the needle, so that if you press it, it will clear any choke, anything is the dust is there, we can clear it. Otherwise, this will vary your total output. Okay. This air is going inside and it is passing through the orifice. It will become to 0.2 bar now. See, it has become 0.2 bar. So whatever the this 0.2 bar, what will happen? Directly it will go to orifice. Okay. So after the this orifice, it is 0.2 bar, and it has to release through the nozzle. If the flapper is too far away, then whatever the air it is coming here, it will go to the atmosphere, and this bar will become 0 bar, 0 pressure. Okay. Suppose if it is because of this movement, because of higher level acting on the bellow will push this power bar. This power bar will pull this plate, this transmission plate. Move the flapper very closer to the nozzle. So the gap between the nozzle and the flapper will be very less, so that the back pressure will increase. Depends on the variations in the DP cell. Okay. So this is actually what is happening. And here it is a relay unit. We will see how the relay unit is working. Relay unit, here what happened, we are giving an input air, it is passing through the orifice we saw just now. But before that, one branch is going inside one valve, input output valve is there. This above the valve, the pressure is acting on this. It is having one triangular valve. This is what we saw in the relay principle. This is the valve. And it is having a diaphragm. This pressure diaphragm is there. So below the diaphragm, we are giving the output back again. They see after the orifice, the air is going out. Okay, the same air is going back to this bellows also, this diaphragm also. So whatever the variation here, it will act on the diaphragm. This diaphragm, what is happening? It will push. If suppose back pressure is more, this diaphragm will push the valve and open the valve. If you open the valve, automatically this air will go and it will go to the output. Okay. Suppose this pressure is very less, what will happen? Here the valve will open it, and the air will pass through between this diaphragm, and it is having one bleeder hole. Through the bleeder hole, the air will escape. Okay. Through the bleeder hole, the air will get escape. So this is the leak off line. So this valve move up and down and maintain the output pressure depends upon this input back pressure. Okay. This input back pressure variation directly transferred to the 1.4 bar variation here, 0 to 1.4 bar variation. That means that we are boosting actually. It's like a booster, signal booster you can say, or pressure booster you can say it. So the same output we are giving to the bellow. This is the feedback bellow we given here. How the feedback bellow is, and this pivot arrangement is what. Now how the pivot arrangement and this feedback bellow system, how it is arranged, how it is set up there, we will see. So now what is happening here, flapper nozzle is operating here, depends upon the DP cell output. Okay. Now the flapper is fitted in one rod, floating rod. This is called floating lever. This floating lever, it is not connected with anywhere. You see here the one pivot is there. This is a movable pivot. It is having a screw rod in the floating bar. So if you turn this nut, what will happen? This nut will go up and down. So if it is going up and down, then it's look like a pivot. This is touching on the flat surface here, so that if it is very down below, then the leverage will be less. If it is more upper side, then leverage will be more. So this is the pivot point. You are going up and down. This up and down we can adjust for the adjusting the range of the transmitter. Okay, so like a span or a range you can adjust with this this adjustment. Okay, so this floating bar, this pivot is this one. This is the acting as a floating bar. Okay, now what is happening? This is connected with the one plate here. This plate is touching the feedback bellow. So whatever the reactions here, if it is suppose pushing this flapper towards the left side, what is happening? Due to the pivot, this at bottom of the floating bar will go other side, opposite side. If it is left side, this will go to the right side. Right side means it is pressurizing the back pressure the feedback bellow. So the output is acting against that, so that this both will get compensated, and then your output will get very exact output. Whatever the minimum changes, minute changes in the level also, it will transfer to the output and you will get the proper output signal. So that is why they added this feedback bellow, positive feedback bellow, and it is having a zero adjustment also. Okay, so if its tank is empty, you can adjust with this, so that the level, this transmitter will show the zero level. So in this way only it is working on separator level transmitter using flapper nozzle system and pilot relay system. Okay, this is not an automatic controller or something, but this transmitter is used for auto pump cut in cut off, or pressure reducing, or whatever the controller. Otherwise you can use for the remote level indicators also. This can be used in your remote level indicator. Maybe this one will be in the tanker or pump room or some other places. You can see the level in the control room. So you can transfer this output to anywhere. So this system, that electrical officer, he wants to know, he was working in this machinery, he is having some doubts. So that's why I made this video, and then I thought it will be helpful to all other guys. That's why I made it with a small animation and clear explanation. I think this will be very useful. Give me your feedback, so that future slowly like this, whatever the things I am facing in the ship, or attending otherwise my juniors asking some doubts also, so that I will put in the video, so that it will be helpful to all guys. So please pass your comments on this comment section, so that I'll get the proper feedback, so that it will motivate me to make more videos in like this. So please pass on this to your friends also, so that everybody will get the benefit of this video. Thanks for watching.